morning, everyone, and welcome to the BeFutureReady webinar series. This webinar series is designed to provide you with valuable information on a range of different topics, and it's there to support you when thinking about your future and the potential career pathways that are open to you. So today marks our third webinar, and I'm delighted that we've got David Hill with us today. Before I hand over to David, however, I'd like to remind attendees of the format. So David's going to run through a short 15-minute presentation on the topic of careers in data science before leaving some time at the end to answer some of your questions. Please write your questions in the chat whilst the session is running, and we'll look to get to as many as we can before we finish up at around 11:20. Any questions that we don't get to, we'll be sure to send around follow-up answers afterwards. So as I mentioned before, David is going to be talking to you about data science careers. David is a senior lecturer at the University of Portsmouth. So David, over to you.
Thank you. Let me just make sure I can share my screen. There we go. Okay, so yes, good morning. I was asked to give you a short introduction to data science. Before I start, it's worth noting there isn't a definition which everyone agrees on. There was an article in Forbes actually fairly recently still referring to data science as a buzzword, but I think we're all using it a lot more now, even if it is a buzzword. And the term data science in its modern form, so it became widely used in the early 2000s, and data scientists generally are people who collect, shape, store, manage, analyze data. And when it comes to collecting data, you'll often hear the term big data. So it's probably a good place to start, see what that is and why that's useful before we understand what sort of careers you can do. So he says, trying to find the button to click onto the next slide. I need one of those people that I can go next slide to. So what is big data? Well, we can think of big data as being defined by 4 V's. There's other definitions, but these 4 V's appear most commonly in what we define as big data. So if we look at them very quickly, 4 factors of big data. Here we've got volume, and we're talking large volumes, especially if we just consider what data is collected on the internet. So if we look in 1992, we're generating new data at a rate of about 100 gigabytes a day, or 36.5 terabytes a year. 5 years later, it's jumped up quite a lot, obviously, as the World Wide Web came into being between those 2 dates and was being more widely used. Then we had Web 2.0 by 2002, and we've gone from 100 gigabytes an hour to 100 gigabytes a second of new data being created. And in 2013, 30 gigabytes a millisecond. In 2018, 50 gigabytes a millisecond. And the last data that I had, or I could find, we're now around 100 gigabytes a millisecond, or 3.1 zettabytes a year of newly created data being generated. So everywhere, all these places creating data, and it's not just on the internet as well. You know, your school, colleges, businesses are all generating their own data as well. So we're talking huge volumes of data that we can use as a data scientist. So moving on to the next V, variety. So whilst often data is just sort of being nice structured data that you find in databases, yeah, probably true in the 80s and early 90s, but you know, we're getting a lot of unstructured data in different forms and different places. So if I take a pre-COVID typical day, I should say, where does the data come from? Well, if you have a Fitbit like I do, you know, I wear that at night. It's generating data, collecting new data all the time, being stored as my Nest system in my house will recognize what the temperature is. Obviously not today, but if it's a cold temperature, it will recognize that and turn the data on. It will monitor my habits as well and start having that data. My Digibox, my Virgin or Sky Digibox, you know, it recognizes things I might like and start recording. So it's generating data there. Head off using my sat nav, and again generating data of where I'm going and where I'm going. Cameras, which if any of you drive, you may see these cameras all over the place. If you've not really noticed them, once you know they're there, you might notice them a bit more. But A roads and motorways will have them. These are CCTV cameras, and they're capturing number plates and they're monitoring traffic flow. Also, if the security services or police need that, they can access them as well and monitor where people are. But you know, this is how, when you use apps on your sat nav and they tell you how fast traffic's flowing, they're collecting data from this and monitoring how fast the average traffic is going between one place and another. Go to my university, swipe in, and it's generating data there. Go to Costa Coffee, and my card, I'm using social media, again, generating data, uploading images, uploading text. Go home on Club Card, again, that's generating data as well. So, yeah, in a typical day, there's a whole variety of data, and they're not just being stored in databases, they're stored in unstructured ways as well, but it's all data. So moving on to the fourth one, we have velocity. So very closely linked to the other two, it's how quickly data is being generated. So you've already seen from the volume and the types and variety, you know, we're talking huge amounts of data being generated. So if we take Instagram, for example, on a typical day last year, there was about 90 million pictures being uploaded to Instagram each day. So, you know, a huge amount of data being created all the time. But that still doesn't come close to what Facebook, so a typical day on Facebook last year was generating around 350 million images being uploaded to Facebook all the time. So, you know, it's not really surprising that they reduce the file sizes when you upload them. I think we've got time. Hopefully this will work. Can you see that? Is that coming up, a tweet map?
Yeah, I can see that.
Yeah, so this is a real-time tweet map of tweets being generated. Those little red dots you see are new tweets being generated. This is only a fraction of the Twitter users being used. These are just people who've got location data set on. So you can see these generations going in, and we can go in and we can explore a bit more, and you can see where they're being generated. You can go in and actually explore the tweets, but because I can't verify what people are tweeting, and there might be some things that we might not want to see, we won't bother looking at that. But you know, that's called 1 million tweet map. So it shows the last million tweets. And just at the time that I've been speaking, you see this counter up here, generating the number of tweets. I'm up to 1,000 tweets already since I started speaking just with that data. So we have got, you know, volume, we've got our variety, and we've got our velocity. And, you know, again, coming back to variety, you know, Internet of Things, those Nest thermometers, light sensors, they're all generating data, you know, taking that data every second sometimes, or sometimes even less. Our last V that we need to be aware of is, he says, trying to get it all to come back on, veracity. We also have to consider how accurate the data is. So the trouble with all this generated data, some of it's going to be incorrect. So it might just be a faulty sensor, for example, or it may be someone, I'm not saying my sister has been known to this, fiddling how many steps they've walked just to say they've got to the 10,000, or even data being misattributed to where it originally came from. So, for example, this company here did some research into how much new data was created in a day. So, you know, when I was researching and seeing, you know, the slide on volume and the amount of data, and they produced this infographic every year since 2013, which was their first release. And in that first release, they did a press release, and they noted IBM was saying that new data amounted to 2.5 exabytes a day, which is where I got my 2013 data from IBM. Every year that they produce this, they still reference that IBM statement, which if you look at it, it does say 2013. But lots of people don't look at that. And so if you Google search how much volume of data is collected, whatever year you choose to look at since 2013, it's always 2.5 exabytes a day, because they're still referencing it and they're misattributing the date. So it'd be very easy to collect data saying how much data is being collected, and all of a sudden you'll get this graph where you've got this nice static from 2013 of 2.5 exabytes a day. So you have to attribute the data correctly. We have to check where the data's come from and how it's being used. Sometimes that data is generated, and we'll touch on this in a little bit about machine learning. And if we don't understand how data is where it's coming from and being able to understand it, we can get some biases formed. So you may have heard of this example. So Tay was a Twitter chatbot built by Microsoft and released in March 2016, and had this account handle at Tay and you. So Tay was a way that Microsoft was investigating whether machine learning, collecting data, using it and creating a chatbot that can respond to answers. And it was mining interactions with others to figure out how to chat like a person and using colloquialisms rather than coming across as a robot. And Microsoft, when they were developing it, was, well, we'll have it with the personality of a 19-year-old girl. But unfortunately, as it turned out, as you can probably imagine, some of the issues on Twitter and some of the accounts that go on there with some nudging, some real people in the real world, affected how she spoke. And she developed the personality of a 19-year-old girl who supported Hitler, hated immigrants, believed conspiracy theories, and generated all sorts of awful tweets, really. Things like, in capital letters, "We're going to build a wall and Mexico's going to pay for it." Microsoft very quickly shut her down after that. So yeah, that's just, not being able to collect the data and check where it's coming from and checking how valid it is for what you want the purpose. And other examples are Compass, which was a US state system that was used to work out what the chances of offenders are going to repeat, and if they are likely to repeat, they're more likely to get a custodial sentence rather than a fine. But obviously it used historical data, and there was issues from historical data where certain people of certain races were more likely to be considered jailed for smaller violations, and that fed back in and ended up in a issue where people were wrongly being mislabeled, whether stating they were white defendants being low risk and black defendants being high risk. It wasn't using data correctly, so again affecting people's lives. Google ad settings, even then, Google themselves had problems where there was bias built in, generating ads, recognizing whether someone was identified as male or female and showing job adverts relating to what they expected a male applicant would look for or a female applicant would look for. But again, used historical data, and obviously, as we know, that in the past, certain jobs were more likely to be have a male involved or a female involved, and so became quite discriminatory. So we have to be clear when we're looking at data, not just the amount of data and how quickly it's being generated, but also we still have to check the validity of that or the veracity of that. And this is where data scientists come in. So it's taken me a little while to get to data scientists, but this is a quote by Hal Varian, the chief economist at Google, just over 10 years ago, but still valid today. Data scientists need to understand how data is connected and select what's relevant, take it, analyze it, and communicate it so it can be acted on. So that leads us to that idea of analyzing. We have to understand big data. Data scientists have to understand big data, have to understand all these things in order to be able to analyze it, which leads us into machine learning, which I touched upon. So with such large, often complex data sets, data scientists will often use something called machine learning to extract the critical information in data sets. Machine learning is a form of AI, artificial intelligence, that enables systems to learn from the data rather than explicitly programming, if this data comes in, do this. So we teach the machines to do that work for us. So data scientists will program that using a variety of language, from Python to specialized languages like R. Machine learning is not a simple process, and we don't have a huge amount of time to go in and all the different ways of doing that. Basically, they can either be trained with the help of a human, or we program it so it can learn from itself according to some rules. Obviously, there can be issues with that, as we saw with Microsoft's chatbot. So, programming, have to be very careful about making sure what's come in. And as you can see, data scientist is multidisciplinary and sort of uses a combination of skills. So here, we've got quite a simplified thing, but they're the 4 common key skills that we tend to associate with data scientists. The computing skills, so the programming, the math skills for understanding how to apply and adjust the data, but also knowing what data that you want and how it's going to be applied and how it's going to be used, the business side, and even more importantly, the communication. It's all very well generating all this, but you need to be able to explain how this data is useful and why it's valid and why it's useful. So that ideal data scientist sits in the middle of all of these areas. So data scientists bring structure to that data. But if we've talked about the variety of data, where could data science take you? What's it good for? So in years and centuries past, managers would just say, well, I've been in this business a long time. I kind of know if we do this, it'll probably work out. And sort of that intuition is now given way to more scientific analytical thinking. And this is our data scientists. So with some data science, you can make accurate forecasts. And this means new organizations have considerable data that they can suddenly realize that is a valuable asset. And in fact, you're probably aware, online companies, if you're not paying for the service, it's because they're collecting your data, and that data is value in itself. They know, data scientists, organizations that use data science, they know how to roll that data together, organize it, analyze it, and use machine learning to learn from it, so it can be turned into decision and actions that sort of can benefit their business. And we can go back quite a while to see where it's being used. Club Card is probably a good example of where that happens. So loyalty card programs, which know which foods you like, what you've bought in the past, can recognize things, and we can build other things. So if the weather's improving, it knows we can apply the weather with past data purchases, and it knows to send that customer a voucher for sausages and barbecue breaks, because they know the weather's going to be nice and hot in a few weeks, and they'll know that, and they'll go out and use that. And if they're in the shop buying that one thing, they're going to buy other things. Or it can be used for to support people, help people. So credit card fraud prevention. So no longer waiting for a human to identify that there's something's happened, building in the data, using data scientists to build programs to identify when things get flagged up on your account. So a computer can automatically initiate someone to contact you in real time and look through it in more details. So where else data scientists make a difference? So one area I think is particularly interesting is areas of medical treatment. So traditionally, patients, they only showed up doctors when they felt some symptoms, and the doctor would try and understand what those symptoms were and confirm it with other doctors and specialists and come up with a diagnosis that they hope would take some action to cure that patient. But with data science, we can get a lot of information about a patient, whether it's lifestyle choices, tests, blood tests, physiology tests, to use them quality of life. So the doctors can have that data as well. So adding into it, we can build programs that can generate things. So they might come in with one symptoms, but that with other historical data can flag things up. Or even we're wearing Fitbits, we can give devices that collect data in real time, so we can monitor that, and we can start flagging things and seeing how that they respond to particular treatments, monitor outcomes, and adjust them in real time. I'm being going to rush through because I'm running out of time very quickly. Industrial areas. So there's an area now called preventative maintenance. So anything with engineering, data sciences are being used by aeronautical engineering companies. And it isn't just about sort of building an engine and turning it over to an aircraft manufacturer. We can put real-time feeds on sensors of gas turbine engines. So it says a day's worth of real-time feeds on Twitter, where it's actually about 100 gigabytes, but each of those data blades is generating data at 520 gigabytes a day, and there's 20 of those sensors on each engine. And aircraft tend to have more than one engine, and there's multiple engines, huge amounts of data. But for the benefits of the engines, rather than waiting for the pilot to say, it's being a bit wrong, having to book it in, that aircraft going out of service for weeks at a time, they can identify faults starting to occur before that. They can book it in, and the downtime is the parts are ready and waiting. So downtime for the aircraft is sometimes even hours. Very last, other examples: TfL on Wi-Fi. If you're in London, may have noticed how things improving. We can monitor things. That free Wi-Fi obviously allows them to track how people are using the systems. And we can see here how they've identified how people use the tube system to go between King's Cross and Waterloo. So in the past with Oyster, you just knew when someone went in and out, but by tracking using Wi-Fi data, we can identify how they're utilizing the systems and seeing how they're using it. So we can see that most people go King's Cross via Oxford Circus to Waterloo. Well, if there's a problem at Oxford Circus, okay, we can't stop there. So they're going to start using other transports where they're more likely to go via Green Park. We know that's going to get busy. So maybe we can then shut the gates to people coming into Green Park, so the people going from King's Cross to Waterloo can use that service. The systems don't get crowded. People have a more comfortable journey. Identifying when tube times are particularly busy and adjusting people's habits in order to make things, increase the capacity and improve the journey for different things. So sort of going quickly back to how, it is an important skill. It's worth recognizing that the impact of those skills can have an enormous impact, not just on companies' financial performances, but as we saw, on people's lives as well. So there's obviously ethics is an important part of data scientists as well. So whilst I talked about all of these programming and the velocity and variety of data, the big data itself, ethics has to become into it. So people going into data science have to have an understanding of how that data can be used and be able to use in an appropriate way. Right, I've gone well over. If you're looking at a job, at the moment, junior data scientists tend to start at about 25 to 30,000, and that recognises the skills that are involved, but also how important they are. And the average salary for a data scientist, according to the UK recruitment companies, is around 50,000 a year. But if you're going into somewhere like a financial sector or something where that data is having can have a huge impact on people's lives, they've got medical and what's happened with COVID as well, generating models about how that, we're talking much higher salaries. So I'm going to look for questions now, Megan. I apologise for running over quite a bit, but hopefully that was useful.
Yeah, no, that was fascinating. Thank you, David. It's it's really interesting to hear how much, I guess, data science is so crucial to so many aspects of life, and the need, I guess, for data scientists going forward. We'll wait to see if any questions come in, but I did have one. I was wondering if you can think of sort of any ways that students who are perhaps interested in a career in data science could potentially sort of stand out when they're applying for courses, or things that they could sort of showcase, or skills that they might be helpful for them to acquire if they're thinking of applying for courses and want to sort of maybe get ahead of the competition a little bit.
Yeah, I mean, obviously it's tricky because data science itself is quite a new university type course, and obviously it hasn't quite filtered down. We're starting to see it in some of the computing curriculums and people use it. But yeah, this link at the top, the IBM link, they've done a nice sort of dummies guide to machine learning, but it'll give you a broad overview of what's involved and what's that. So you can talk a little bit more about that. It is because data science covers everything. It's very hard to pick out particular skills you need to. But yeah, good understanding of programming, the fundamentals of programming is a good place to start. Making sure your math skills are up to date and relevant to what we're doing. If you're interested, having a go. Programming in R, there's some various things out there that you can find where you can have a go at practicing it, but the IBM one's probably a good one to look at. And again, understanding ethical issues, quite often you'll get asked about that as well. So the moralmachine.net is a good one to look at that, and that looks at autonomous cars, which obviously you're using a type of AI, but again, we come back to machine learning. Someone's got to program that. Data scientists are collecting the data and doing that. Is it better for the car to protect the passengers or protect the people? If there's people on the outside, protect them. We have a moral obligation of who do we protect. It's a bit like the trolley problem, if people have come across that before. Actually, another good thing to do is talk to your college. If you're a college, talk to your college about getting someone from the university to come in. So we do taster sessions on all our computing courses, and lots of my colleagues at other universities do the same. So they can come in and do a session, and you'll get a chance to have a greater experience of what's involved. Because whilst lots of universities offer data science courses, they're all slightly different in their own way. So you need to find the right one for you. So you can't just go on the sense that it's a data science course, because they're not all the same exactly. They cover the core bits, but they will certainly have certain things that will be more interest to other people.
Fantastic. Well, yeah, I'm afraid we're going to have to probably leave it there time-wise.